Hi, welcome to this webinar. I don't know if you've ever seen this robot here before, but this is a humanoid robot from NASA's Johnson Space Center. This is Valkyrie. This is the result of thousands of iterations of prototypes. This robot can do lots of things that humans can do. NASA is starting to go away from the traditional direction of making robots that just have a singular purpose to having robots that can do lots of things like humans. So today we're going to be talking about prototyping. We're going to talk about why, what, when, and how to prototype. First, we'll have a brief introduction. I'll tell you a little bit about me and my background, explain why, what, and when to prototype, discuss the engineering design process, and then a brief overview of how we prototype and some ways we create these prototypes. And then along the way, we're going to have some pauses for notes and or discussion. So some tips with regards to taking notes. There'll be a few points where we'll have pauses, and so you're encouraged to pause for a second and make notes about what you learned, make notes of anything you found interesting, or make a list of anything that was confusing. I'm Luke Nogales. I'm a professor at New Mexico State University in the College of Engineering. I primarily teach mechanical design and innovation courses. I have experience making lots of different types of prototypes. I've worked with making missile prototypes. I've worked on even diaper prototypes. I've done prototypes with dog food. And most recently, I finished a prototype of a mini Mars yard rover. So it's a small rover that's designed to go in a simulated Mars environment. So why do we prototype? Pause for a second and try and answer this question. Why do you think we prototype? What's the purpose of doing it? We prototype to learn. That's just what it boils down to. We have a lot of things in our head. We have lots of ideas of what we think is the right solution, but those ideas aren't fully formed yet. And it's good to take those ideas out of our head and turn it into something that we can look at and that others can see, and we can learn from that process. Here's an example of a prototype. This prototype isn't very fancy. It's not very expensive, but it's very helpful, and it really helped a lot of people learn about what they were trying to create. I don't know if you can guess, but this is actually the first prototype for a surgical instrument. This was created by a surgeon who was trying to explain to engineers and scientists how to make this new surgical device. This is what it looked like when they were done. So you can see that this device kind of gave the engineers and the designers and scientists an idea of what this would be like, so that way the surgeon could hold it comfortably. But at the end of the day, we really want to make better products. So we prototype so we can learn as much as we can and make better products, which lead to better experiences. All of us want products that give us a great experience. So prototypes help us communicate our ideas. We've all heard the saying about it, one picture is worth 1,000 words. If one picture is worth 1,000 words, how much is one prototype worth? I would argue that a prototype is worth 1,000 pictures. There's so much you can learn from a prototype when you look at it. You see it from different views and different angles, and you can see the materials, and you can get feedback and thoughts from other people. Now ask yourself, what is a prototype? What counts for a prototype? Please pause for a second and write down what you believe is a prototype. Anything really can be a prototype. Anything that helps us make a better design. So this prototype helped make a better surgical instrument. It wasn't the last prototype that they made, but it was a good starting point that helped them make a better design. It could be sketches. You could be creating a prototype for an app you want to develop. So a lot of apps are developed with just sketches. So you can sketch out what you have in your mind a lot faster than if you had to program it inside of a computer. And then you can go through a lot of ideas quickly and very inexpensively without having the skill of knowing how to program. You could even prototype experiences. So this picture here is a picture of a company that was working to make a better hospital. So they were prototyping the experience of going to a hospital, and they were looking at, well, what does a person see when they go into an emergency room? Who do they interact with? What's on the walls? What are the smells? What are the sounds? But by understanding what that experience is better, you can make a better design. You can also create prototypes that look like your finished product, but necessarily don't work like your finished products. This can help you see how all the pieces fit together, how they work together, whether or not there's going to be any problems with any of the pieces. And it's also a good way to share your idea with people that you're working with. So when should you prototype? When do you think is a good time to prototype? Please take a minute to write down when you think you should prototype. As soon as possible. It's important to start prototyping right away. As soon as you start having ideas and you know what you're trying to achieve, you should be taking those ideas out of your head and start making prototypes. The goal is to make your prototypes fast. So you want to build them quickly and test lots of them. And to do it cheaply too. You want to do it inexpensively. You can go through a lot of different design ideas very quickly, and you especially want to do this in the early stages of developing your design. So let's talk a little bit about the engineering design process. So the engineering design process is a lot like the scientific method, but it's what we use to make new products. It's what we use to make our ideas real. We start off by asking, what are the problems and what are the constraints? What are we trying to solve, and what are the resources and tools we have available to us? Then you want to start coming up with ideas. You want to imagine as many ideas as you can. You can do formal brainstorming and coming up with whatever comes to mind. And as you go through that process, you'll have some ideas that you think are better than others. Choose those ideas and start to put together a plan for how you're going to make that idea real. You can put together a diagram, put together a schedule, get the materials you need to then start creating your actual design. You want to follow that plan and test it. You want to create that prototype and test it and try and learn as much as you can from that prototype. And then finally, after you've tested it, you want to see, well, how can I make it better? You want to improve your design and go through the steps again. So you keep going through this process iteratively, essentially going back to earlier stages to improve the design, because the first time you come up with a design, it's probably not going to be the best design. It rarely is. But it's really important to get that first idea out there quickly and start going through that cycle to come to a better design. So now ask yourself, how can we prototype? Please pause for a second and just think of what's important when we prototype and what do we do to prototype. I think Nike has one of the best slogans in the world, just do it. So I think the key to prototyping is to just do it. It doesn't need to be perfect. You don't have to have everything planned out, but it's really important that you just start making the prototype. It's more about your attitude than the skills and techniques. So if you believe you can make something and you start putting together different parts and start testing out different ideas, that's the most important part. Over time, you'll develop certain skills and techniques that'll help you make better prototypes, but the best way to get started is to just do it. Also, there's a few ways we can look at prototypes. We can make very complex ones or we can make simple ones. So we're going to talk about low resolution prototyping and some materials we might use for that, mid resolution, and high resolution. So if we look at low resolution prototyping, these are the fast and cheap ideas. These are the ones that we put together very quickly. One of the materials that most of us have used are just markers and pens and pencils, and we can sketch out our ideas. We can draw our ideas and share them with other people and get feedback and input on our ideas. One of my favorite prototyping materials is cardboard. You can make cardboard into lots of different shapes very quickly and inexpensively. Most of us have cardboard lying around our schools or at work or at our homes. Hot glue guns are very useful for gluing things together. Scissors are important too if we're going to cut out different shapes, especially from our cardboard. Duct tape and other tapes are very useful. Colored papers can be really helpful too if you want to make one part of your prototype one color and something else another color. So it helps us represent our ideas in different ways. Also, pipe cleaners are really useful. Most of us have probably used these at some point, but these are really good for creating shapes that maybe are harder to cut out or binding things together. You're really only constrained by your imagination. The main goal, though, is to take that idea from your head and start making something physical out of it. Take that idea out of your head and create something that you can show to other people and you can start making better. For mid-resolution prototyping, we have a handful of tools that some of us may have experience with, like basic wrenches and sockets and screwdrivers and hammers and hacksaws. So these help us make maybe a little bit more complex prototypes. We might use a drill or even a breadboard. So a breadboard is a way of connecting electrical circuits together and prototyping how that might work. Or we may even use microcontrollers. Microcontrollers are getting very cheap now. Microcontrollers are just small computers that are very low cost where you can plug things in and get different types of readings. You may also want to use foam cutters. So this is a specialized piece of equipment where you can cut foam into different shapes. And it can be really useful for making something a little bit more accurate than what you might cut out of cardboard. And probably one of the most popular mid-resolution prototyping tools that we have are 3D printers. Lots of people are excited about 3D printers today. We have a lot of them at our university. They are very helpful in turning your idea that you've made on the computer into something real. They work a lot like regular printers that you have for printing on paper, except for instead of just printing one layer of ink, they print lots of layers of a plastic-like material, and these layers get built up one at a time until you have a three-dimensional printed part. Last, we have high-resolution prototyping. So high-resolution prototyping is when we want to make something that looks and a lot of times works a lot like the finished product. So when we're cutting things out of cardboard, it may not look like the finished product. When we're gluing things together with a hot glue gun or using duct tape, it's probably not going to work like the finished product. But we have some tools to make things that are like the finished product. So you might go into a machine shop and use something like a lathe if you need to make a circular shaft. Or you might need an injection molding piece of equipment to make something out of plastic. Or you could use a multi-axis CNC so you can cut complex shapes into a part. Or a CNC mill if you need to make various holes in a part in very precise locations. You might need to weld some things together. Or you might need to have a very detailed 3D printed prototype. So a lot of the 3D printers that people are using today are relatively inexpensive, and the quality is good enough to do the work you want to do. But there's 3D printers that can make almost exact replicas of the finished product. But those 3D printers can cost anywhere from $100,000 to $1 million. So you don't use it very often, mostly when you're just trying to create that high resolution prototype. So let's take a look at some examples of prototyping. To help us think about this next example, I want you to think about how you might reinvent a cell phone case. We've all seen cell phone cases. So just take a second now to think through and maybe even write down some notes about how you would reinvent a cell phone case. So here are a few examples of cell phone case prototypes. So if you see up here, we have several prototypes, and these are low resolution prototypes, low to mid resolution. I had some students in one of my engineering courses who were trying to create a new type of cell phone case. And they wanted to make a cell phone case that was not as bulky as current cell phone cases. And so first they wanted to kind of explore the form and shape of cell phone cases. So if you look at the two prototypes on the right, those are essentially prototypes made with hot glue guns. So they got a hot glue gun and they put some tape on their phones and they poured the hot glue over their phone to get an idea of what that shape is and what might be the minimal amount of material you might need. And is this a direction that they would even want to create something in? And from there, they went to the next two prototypes, the green pieces of foam you see there. And this is where they were exploring different shapes to see, well, what is bulky? How big is something when people think it's bulky? What do we think is bulky? How many inches or millimeters is something before people think it's bulky? It's not something we always think about, but when we have something in our pocket that seems too big, we know that it's bulky. But you can start putting numbers on those kind of things, and the prototypes help you do that. So after that, they decided to make some CAD models in the computer, so computer-aided design models. So these are three-dimensional models in the computer. They designed these, and they then sent these files over to the 3D printer and made 3D printed phone cases. They first started out with the phone case on the left. Essentially, it was a phone case that had a compartment where you could put your ID and your credit card and maybe a house key. And then they said, that's still too bulky. And so they went to the next design, which was essentially a frame that went around your phone to protect it. And then it had a clip holder where you could put your ID and your cards and things like that in there. And they said, we think we can even have less material, make it even less bulky. And they created this, one was black and one is white, these essentially frames of this phone case. And that's all it is that's the phone case right there. So it doesn't protect it all around from scratches, but what it allows you to do is protect it if you drop it, or in addition to that, you can add your cards to it, so that way you can carry your phone with your credit cards and your ID, so you don't have to carry your wallet anymore. So these were some great examples of different types of prototypes. So some final tips on prototyping. Try to follow the engineering design process. You want to understand what the problem is, what the constraints, trying to imagine a solution, plan out how you're going to make that solution, and then make it, follow the plan, and work to improve it. I'd say that the best ideas start with sketches, so it's important to sketch a lot, sketch often, get feedback from your classmates and your teachers on your designs. And then if possible, start turning your sketches into CAD models. Start designing it in the computer, because once you have a CAD model, it's really easy then to turn it into a drawing. So this is a drawing that you could send off to a machine shop and actually get made. And then the one thing that you always need to keep in mind is the customer. So don't ever forget about the customer. So you may be designing a wheelchair, but understand who's the person that's going to be using that wheelchair, and how are they using it, and what's different about your design versus other people, and how does this help them in their everyday life. So this is the end of our webinar. I encourage you to take a second and make a list of 3 things you learned, a list of 2 things you found interesting, and then write a question about something you found confusing. Thank you for your time. I wish you the best of luck with your prototyping efforts.